That demo shows you the idea of return-oriented programming. We look for fragments of code just before a return instruction that will do something that we want to do, and we can chain those fragments together by doing a buffer overflow where we list multiple addresses as return addresses they end up being jumped to in sequence. But for the purposes of that demo, it was awfully convenient that getShellPath was there that happened to provide just the right code to set bensh into RAX. What if we didn't have getShellPath? What if we wanted to construct our own string, some other executable to run? Just for demonstration purposes, let's say I want to run benbash instead of bensh. Is there some way that we can get the string benbash into this program and then have that string get in RAX instead? Well, we certainly have a way to get benbash into the memory of the program that we want to attack, because after all, we are supplying a name here. And instead of just writing 10 A's as garbage, we could write benbash just as well to take up 10 bytes of the name. And then eventually we want to jump to that same spot inside of showDate that runs exec, but we need some other point here that will somehow get a pointer to the name buffer on the stack and put that in RAX instead of the string bensh. And there's just not an existing function that's going to do this. We would have to jump to a function that looked below the stack pointer and put that in RAX, which is just not a good thing for a C program to do, so it's never going to do that exactly. But again, we don't have to call a whole function. We can call just the tail end of a function, which might move some other register into RAX before it returns, and maybe we can get the right pointer into some other register and make that happen. In other words, we have to look through our code for some instructions that do just the right thing. We've already looked at the disassembly for our program, but let's look one more time. We could try digging through this and seeing if we can find just the right instructions in here. But that's all of the code for my program. It's really very small and there's not a lot of choices there. Fortunately, it doesn't have to be just in my immediate program, because when I run my program, it also loads the C library. And there's a lot of code in the C library, and those functions can be a rich source of code fragments. If I go over to, let's use LLDB and load our program again, I will start running it so that I can look at some other code. I'm going to look now at the, what functions are in the C libraries. We're using fgetS, so we could look at that. And fgetS turns out to be quite a bit of code, it turns out. It only returns in one place though, right here. The things that it does just before that are pop a bunch of things off the stack into registers. So what we see right here is some code we might use, and in fact, I'm just going to move that onto the slide here. This is the same code that we just saw at the same addresses. And what we see is if we ever want to pop 6 things off to the stack and put them in these registers, we have a little pseudo function, a little bit of machine code that happens to be floating around in the C library that we can use to do that. And we'll call this bit of code a gadget. So we have gadget number 1 here, pops 6 words on the stack and puts them in various registers. Turns out the first one is RBX here and then some others. That's not quite what we wanted though. We wanted a value in RAX, not any of these 6 registers. But if we back up a little bit in fgetS, we can see the few instructions before that include moving RBX into RAX. That is useful because if we can get the right value into RBX, we can get it moved over into RAX. So gadget number 2 here moves RBX to RAX, and then it does some other stuff that ends up popping 9 things off the stack, the 6 that come after that we called gadget 1 anyway, but also 3 more due to this add queue. Now we have 2 gadgets that do something useful. We can get something off the stack into RBX, and then get RBX into RAX. We mangle a bunch of other registers, but if we don't care about those registers, then this can be just right.